Hello everyone, day 17 with Rust. Let's go. We've got a tunnel and rocks are just falling down, right? You can see the rocks in here. Those are the shapes of the rocks. And if you do have a feeling it's Tetris, you're right. You're correct. Yes, it is Tetris. Let's go with it. You do have a jets of air. So there's actually air coming from left and right side. So it's blowing the rock. Like imagine how hard of a air blow it needs to be to push that freaking rock to the side. But yeah, our little corridor is 7 spaces wide. Whenever the rock is falling, it's always falling down 1 space at a time. Important part. And it actually starts with a side movement first. So first you've got the horizontal shape, which happens like they all spawn in the same space. Then it goes sideways according to that little pattern we have of the air. Then it will fall down 1 unit. Then it goes again to the right, but it cannot go further, so it just falls down once again. Then it actually pushes the rock to the left, and then in the end it tries to fall down once more, but it cannot. It actually hit another rock, or in this instance it hit the floor. So now it's a settled rock, so another rock will fall on top of it, obviously. And then you learn that you actually have to calculate for 2022 rocks. Alright, let's see the code. I did start a little bit different this time around. So I started describing the solution. So this is what I usually try to do. So for some reason when I started doing Rust, it kind of fell off my head because I was so focused on Rust that I didn't really take into account the actual domain that much. So now I got back to really focusing on the domain. We have the air jet blowing direction, either left or right. Then you've got the air jets. It is a vector of the blowing direction, but it ends somewhere, right? We learned in the task that it actually cannot end, it just loops around. So whenever you grab the result and you adjust the index, you always need to take care of adjusting the index so it loops. You've got the point, you've got the side, then you have the shape movement, and the movement can go either sideways with the side here or downwards. Then you've got settled shape, and this will be different to the shape. Each rock has a different shape, which is represented for me by vectors of points. So I do have the anchor, which is lower left corner of the rock image, let's call it that way. And yeah, that's the whole idea. So you move only the anchor between rounds. And the difference with the settled shape is you no longer have an anchor because it's just the points where it landed. So the points are recalculated based on the anchor, and this is just the settled shape which will never move again. Whenever we move the shape, we need to understand whether the shape moved is already settled or still falling down. So this is the differentiation I've got. So we either have the settled state or the falling state. Shape can easily transform to the settled shape. We've got rock kind. There is actually 5 kinds of rocks. They all have different shapes. Rock kinds is then converted to shape, which doesn't only contain points, but also the anchor in here. We've got the rock source. So similarly like the air jets that are giving us the different blowing directions, we also have a rock source, which will hold vector of rock kinds, and it also will hold the current index, keeping in mind it has to be perpetual, it has to be always repeating. Alright, we've got one more thing to cover in here. So this is move shape. Now I'm using the mutable reference for self, so I'm adjusting self, which is the shape state. Other option or different option was to actually move self, so once again thinking about borrowing, and then we could return a new shape state, so a new self. But I just thought to myself that it's kinda hard to read actually. I'm used to this because I did program a lot of F#, but I think the line below just looks a bit cleaner, a little bit better. If we are actually already settled, don't do anything. If we are falling down, then we go into few different options. We are grabbing the shape out of that falling state. Then we match the movement, either sideways or downwards. If we are going downwards, then we have the new shape, which we adjust the anchor of. So just in case, I have added in here the possibility to fall out of map. Let's not focus on that for a second. Let's go further. We are actually running a function rPoints_free in the map, if those points that the new shape would take are free or not. If they are free, then we are still falling down. So when we are moving downwards and we hit something, we end up in a settled state. Similar thing happens when we move sideways, but in sideways possibility, we can never go to settled. If the points are not free, then we just don't move. Let's move on to map. So we're starting up with constant values. We could push them around as parameters, but I used constants in here. It made more sense to me. This one, maximum map height. Well, I decided that the map that we build, we don't have to retain all of it in the memory, so I retain only the highest 50 levels of it. Let's take a look at the map. And map is very simple. It's a hash map based on the points with Boolean value. Boolean value corresponds to whether the space is occupied or not. If we are creating a new map, so we create a new mutable map, then we build the floor. And building the floor is just putting the points that are on floor level, well, from left wall to right wall. Next step is to grow map accordingly. It uses that map growth constant. It uses that constant to just create 4 levels of the map, including in that the left wall and right wall is actually occupied. So bear that in mind. And then we also run retain top of the map. Retain top of the map holds on to the top 50 levels of the map. 50, which is specified in maximum map height. And since occupied spaces is a hash map, the retain function is actually very useful in here, so we're just holding on to the points that satisfy this condition. Since the rock towers is growing with each round, we need to take care of the starting position for each and every rock. And this is done in here. We do have the x, which is constant, and then we get the highest point in the map, and then plus map y growth, so actually +4. This one is also interesting. We filter out only the points that are occupied, which are not walls. Then we grab y coordinate of those points, and then we take the maximum one. And then we've got the important bit. And the important bit is how tall is the tower. We grab from the input, we grab the air jets. Then we create a new map, which will already have a height of 4. And then we go step by step. We grab the new rock position. Between the rounds, that rock position changes only on the y-axis, but it does change. From the rock source, we grab the next rock, then we convert it to shape within that new rock position that we just calculated, and we wrap it up in the falling state, because we always start the rock in the falling state. Then we have a while loop, and in the while loop we always move first sideways, then we move downwards, always one step at a time. So after the while loop, we'll always end up with the rock, here rock, that is actually in the shape state settled. In Rust it's quite easy to have that if let. How do we read that? So we have the rock, and if that rock is actually the shape state settled, then we move out the value into the settled shape variable. In the end, to the map we are adding that settled shape, and just to remind you, when we add those few points of the rack, then we grow the map so it always is high enough to accept a new rack. So first cargo test, here we go, finished, all happy, all dandy. Then we go cargo run, here it is. So this is my outcome after 2022 runs. And then we go into part 2. I just have a very short message to Eric, to the person that created Advent of Code. You just baited me, mate. Like, you seriously did that. Ah, that was such a bait. Oh my goodness. Alright, I saw the task and I see that this kind of well or this sort of tower is only 7 spaces wide. I can easily just work with building the whole map. That's not an issue, right? And then in part 2 you have to go through this number of rounds. Well, first of all, it actually forces you to use unsigned 64-bit integer rather than 32, but it also takes like freaking forever. I'm sure it would work, but I didn't have enough patience to actually hold on to see that complete. But either way, it's like what the hell? It's such a huge number. I feel so jabaited. Damn it! This is why I wasn't able to complete day 17 part 2 yet. So yeah, I probably have to think about some other possibility how to do that. So this is officially 1 trillion rounds. Yeah, I feel so jabaited. Well done, mate. Well done, well done. I have to think of, well, different idea. But that's coming next. Thank you very much, guys. I'm happy you've been here, and I'm happy I had some fun with Rust. Thinking about borrowing and memory is a sort of a fresh look for me. I really enjoy that. Thank you very much, guys, and as always, we can do better as a pack. Bye. So according to the pattern, well, first we go to the right, oh sorry, this way around. First we go to the right, then to the right, 3 times to the right, then to the left, and so on and so on. In this instance, it hit the floor. Let the bodies hit the floor, right? Alright. And after a while, we'll always end up in a place where we are actually looking at the once again.